Greetings, I'm Tommy and welcome to Project World Asia. We are an innovative group of three aiming to use our YouTube channel to share with you a new perspective on global issues pertaining to Asia, one that focuses more on the facts and the bigger picture. Given that Asia is often misunderstood and hidden behind political agenda and media, it's important to have accurate and relatively unbiased information. We will be starting our journey with a recurring problem that the whole world faces but is of particular concern in Asia, and that is air pollution. Air pollution is a general term that we use to describe the introduction of any harmful or poisonous substances into the atmosphere that can cause a wide range of health issues. It has been mentioned countless times in news articles, climate protests, and YouTube videos. Although most of us know in general what air pollution is, we tend to not understand it to a great extent. This, therefore, raises the questions of what exactly is air pollution, and where does it come from? Why and how does it harm us? Now, before we get into the whys and hows, we'll first investigate the crucial where, the origins of air pollution. In our society today, air pollution is often associated with the burning of fossil fuels and firewood. Though there are other smaller, natural contributors to air pollution, such as dust and pollen, we generally disregard them as they only affect our health in localized areas for short periods of time. Widespread air pollution, on the other hand, is driven primarily by the artificial and natural burning of coal, petroleum, and wood. One must not overlook Mother Nature itself, as things like natural disasters and extreme weather conditions also contribute to the problem. Earthquakes, for example, can cause infrastructure to break down, often causing widespread fires. These fires, fueled by gas leakages, can rage on for days upon days, pouring thousands of tons of pollutants into the air. Another example would be natural wildfires, which can cause a large amount of particulate matter and harmful gases to be introduced into the atmosphere, oftentimes making it impossible to stay in the local areas for even short periods of time without receiving permanent harm. However, in the long run, with the exception of a few long-term cases, these natural disasters generate relatively small amounts of air pollution in Asia compared to the controlled burning of fossil fuels in its southeastern countries, and are more prevalent in non-Asian areas like Australia, Northern Africa, or North America, where the relatively dry environments pose dangers of wildfires. The main factor responsible for air pollution in Asian countries is the controlled burning of fossil fuels. Burning fossil fuels provides us with the energy in the form of heat, which is converted into mechanical energy and vice versa. There are many different forms of fossil fuels, but the most commonly used for this purpose are petroleum, coal, and natural gas. While the burning of natural gas releases relatively low amounts of organic oxides and particulate matter, the other two fossil fuels release the majority of the particulate matter and organic oxides associated with air pollution. This burning of fossil fuels does drive the economies of many Asian countries, but also releases the greatest amounts of pollutants on an annual basis, especially with the burning of coal. In order to understand the source of this issue beyond these fundamental aspects, we must look at what exact pollutants contribute to the massive air pollution in Asia. Pollutants are defined as substances that have a negative effect when introduced into the atmosphere. These substances, for the most part, are unwanted forms of normal chemicals, like black carbon. They are either produced artificially by the controlled burning of coal, or naturally, such as with the case of ozone. Nevertheless, whether natural or artificial, they are both at the core of the problem. 5 pollutants in particular, PM2.5, PM10, tropospheric ozone, aerosols, and hydrofluorocarbons have the biggest impacts and thus will be the main pollutants discussed throughout the video. Since we've already given you the background on the air pollution problem in Asia, we will now discuss its effects, the things that makes the issue so pressing. The first and most concerning effect of air pollution in Asia is its consequences on human health. To better understand this, we must look at certain statistics. In 2015, the World Health Organization estimated that less than 8% of the Asian population enjoyed safe air within the WHO guidelines, meaning that roughly around 92% of 4 billion people suffered from dirty and polluted air. In 2018, 7 million premature deaths worldwide and 215.5 million disability-adjusted life years were attributed to ambient and indoor air pollution. This is due to, as a 2016 GBD study states, a population-weighted annual mean concentration of PM2.5 in the Asian and Pacific regions that exceeds the WHO's safety net by about 400%. The burning of fossil fuels, such as wood, coal, and crop residues in Asian homes for cooking and heating being the major culprit. To put it into another perspective, Let's look at the established WHO mean ambient air quality. This system ranks air quality based on 3 different interims: interim 3, 2, and 1. Interim 3 air quality is measured as 15 micrograms of pollutants per cubic meter. Interim 2 is 25, and interim 1 is 35. Asia, unsurprisingly, falls under interim 1, meaning that not only does it have one of the worst air qualities in the world, but also one of the most unhealthy atmospheres. Another major concern is air pollution's effects on the regional and global climate, something that affects all of us in one way or another. A 2016 UNEP study noted that the average temperature of South Asia's atmosphere was increasing by a worrying rate of 0.25 degrees Celsius per decade, which increases the frequency of extreme natural disasters. Changes in Asia's temperature affects the chemical production and loss rates in our atmosphere and the amount of precursor emissions. Asia's local and regional circulation patterns also differ with changes in our climate. Various notable greenhouse gases include nitrous oxide, water vapor, ground-level ozone, sulfur hexafluoride, methane, chlorofluorocarbons, and most of all, carbon dioxide, some of which contribute to ozone depletion while others reflect infrared light emitted from the surface of the Earth back towards us. Generally, the emission of these greenhouse gases come hand in hand with air pollution, as most are derived from the burning of fossil fuels. Air pollution and the rise of global temperatures also affects many parts of Asia through the diminishment of glaciers and ice in the Asian cryosphere. The Asian cryosphere is taking a huge blow due to the effects of climate change, and many studies have shown this to affect human life. For example, approximately 18% of the world's water drains into the endorheic basins, which are secluded and inland. The disappearance of these small basins leads to a lower overall river discharge, which has negative effects on agriculture and life, causing an increase of urbanization in rural areas during the 21st century. This has caused many Asian regions to experience droughts, flash floods, and mudflows at the upper and middle river areas. Soot, a product of air pollution, accelerates the retreat of the Asian cryosphere. When soot is deposited on the glaciers, the albedo effect is reduced, increasing the amount of sunlight that is absorbed. This is of global significance as roughly 1.4 billion people in the world rely on the glaciers in the Asian cryosphere for clean drinking water. A chemical compound known as black carbon is a major contributor to the retreat of the cryosphere. Sadly, the amount of black carbon received by the Himalayan Tibetan Plateau increased by 41% from 1996 to 2010. South and East Asia are mainly to blame, accounting for 67% and 17% respectively of the black carbon transported to the region on an annual basis. While stratospheric ozone protects us from harmful UV rays by absorbing it, ground-level ozone, or tropospheric ozone, causes harm to living beings. Ground-level ozone is produced when various emissions, such as nitrous oxide and volatile organic compounds from fossil fuels, react with sunlight. Besides health and climate, another area that's significantly affected, yet less known, are the global agricultural sectors and ecosystems. This is quite important as the entire global populace's survival requires sustainable sources of produce and a suitable environment to live in, or else we'll all. In this realm, tropospheric ozone is the most damaging pollutant, as it was estimated by a 2018 UNEP report that overall crop yield in Asia was reduced by a range of about 5 to 30% through the effects of ozone, referencing at around 50 parts per billion. It's also known that even exposure to relatively low levels of tropospheric ozone, less than 40 parts per billion, are known to have negative effects on crop productivity and natural ecosystems. It gets even worse as monthly mean ozone concentrations now commonly reach 50 parts per billion during important agricultural growing seasons, resulting in crop yield reductions in many Asian countries. Examples include the relative yield losses of wheat for the whole of China, which was in the range of 6.4 to 14.9%, or the rice yield loss in the southeastern part of Vietnam in 2010, which was in the range of 0.51 to 5.7%, varying with crop cycles. Even India, one of the world's agricultural powerhouses, experienced a loss of 4.2 to 15% of their total wheat crop and 0.3 to 6.3% of their total rice crop, with their projected ozone emission levels in 17 areas. What does this all mean for the future? Well, according to the UNEP, given projected increases in ozone concentrations in East Asia, It is estimated that grain yield loss would increase by 2 to 16% for maize, rice, and wheat, and 28 to 35% for soybeans in 2020 compared to 1990. This is crucial as if air pollution policies are not strengthened, crop production losses in 2050 might go up to 10 tons per kilometer squared, thus meaning that crop area requirements must increase by an additional 8.9% in Asia. The urgency of this problem is underlined by the fact that Asia is distinctively subdivided in terms of agricultural development. Certain areas like Japan or South Korea with limited land have experienced rapid urbanization and industrialization, thus increasing the need for more and more land to accommodate this growth, whereas other areas in Thailand and Indonesia have the land but very limited technological advancements in agriculture due to slower industrialization. Air pollution, surprisingly, can have severe repercussions on the global economy. Different from agriculture, the main pollutant in the socio-economic realm is PM 2.5. According to the World Bank, in most cases, levels of PM 2.5 stabilize with consistent economic growth. However, in the case of many Asian countries on the lower income spectrum, annual exposure to PM 2.5 often will be higher. Now, in order to fully understand the socio-economic effects of pollution, we must reflect on how people in Asia obtain and use energy. The use of coal combustion to produce electricity is one major factor contributing to high levels of PM 2.5 that affects Asia's air quality, even though many countries like China and Indonesia have taken severe measures to control it. Another major factor that contributes to the problem is urbanization. A 2016 report done by the United Nations Economic and Social Commission for Asia and the Pacific shows that because the energy demand is expected to increase by 32% in 2040, the implications for the environment in terms of pollution then are quite significant, as urbanization is a key contributing factor to high air pollution, particularly when the demand is based off the need for dirty energy sources like fossil fuels. All these factors thus result in massive socio-economic consequences, particularly within the economic sector. According to a 2016 report done by the IEA, air quality is a determining factor relating to urban management, as poor air quality often leads to a certain amount of reduction in GDP, such as in the case of South Asia, which is a region who loses up to 0.83% of its GDP because of poor air quality. This becomes a massive concern because despite only having 40% of the world's population, the Asia and Pacific region accounts for 80% of the urban GDP. Pollution thus does not translate into money for the long run. On a global scale, air pollution can be like a fire, silent but deadly. Indoor and ambient PM 2.5 pollution, for example, is associated with 7 million premature deaths each year globally, according to WHO. Additionally, air pollution can cause sickness and worsen living conditions for those who are already impoverished. The World Bank also estimates that deaths induced by air pollution costed the global economy about $225 billion USD in labor income in 2013 alone. As the decade proceeds, we have also seen more extreme and more frequent natural disasters. In the long run, air pollution, combined with greenhouse gas emissions, can also accelerate climate change, causing widespread droughts, wildfires, and extreme weather events. Air pollution is a problem that affects millions around the world. It has killed millions and will kill millions more if further action isn't taken. In Asian countries especially, where the majority of the countries are LEDCs or NICs, the necessity to reduce air pollution remains high despite several advancements in the last few decades. Therefore, we have come up with a few possible solutions as to what could be done to reduce air pollution. Although a lot of our solutions are targeted at the higher powers, it is also up to us to raise awareness and to educate. Another big issue with air pollution in general is how the impacts are never immediate and can always be looked at as a contributing factor. The media, where most of us get our information, often portrays the somewhat instant causes of death in a more severe light, pushing air pollution off to the sideline. Also, since the impact is not automatically detrimental, reducing air pollution could be seen as an unimportant issue for developing countries in Asia or within the BRIC group, as the economic success of them is what keeps their governments in power. Generally, and unfortunately, money comes before breathing clean air. One last thing we should keep in mind is that even though resolving air pollution is a key priority within our society, it walks a treacherous line surrounded by much economic backlash. Many large industries are against it, particularly those who deal in energy and oil, as catching on to the issue of air pollution will only bring them misfortune and loss of profits. Whole countries may be against it as well due to the limitations that resolving air pollution puts on many Asian countries in terms of economic growth. China, India, and South Korea being 3 examples of that, since though they are major polluters, these nations are part of the new drive in the global capital and key contributors to the entire world's economic machine. And while us in the West often condemn their actions, we must recognize that much of what they're doing now are things that we ourselves have done in the past. One thing that is very clear for us here at Project World Asia is that a major shift in the energy sector is necessary to eliminate or at least reduce air pollution. Without it, clean air over not only the skies of Asia but also the whole world will nearly be impossible. One option is for countries in Asia and the Pacific to take more sustainable socio-economic development pathways. Clean fuel use and urban planning could allow them to continue on their road to developed nation status, while still being able to manage their local air quality. This, too, contributes to climate change mitigation by decreasing greenhouse gas emissions. This is vital as UNEP predictions state that future ozone concentrations in the atmosphere will increase by 5% minimum, which could cause our stratosphere to heat up quite significantly. Other possible solutions involve a shift from fossil fuels and biomass energy production methods to cleaner, more sustainable sources, such as solar, wind, and hydropower. Energy policies, especially the shift from coal and biomass to cleaner fuels, avoided a 50% increase in primary emissions of PM 2.5, and dedicated pollution controls avoided a 20% growth, according to a survey conducted in 2019 by the United Nations Environment Program. However, countries that depend heavily on the cheap, quick burst of energy provided by fossil fuels, especially the NICs, to support their economies may not be able to make this shift completely, though there are still measures that they can take to reduce the release of particulate matter, thus alleviating the problem. A more interesting and not commonly discussed solution would be the mandatory installation of industrial filters that are capable of filtering out sulfur dioxide, ozone, and particulate matter that can reduce air pollution. Placing a tax on the emission of particulate matter, similar to the carbon tax in Canada, can also encourage the industrial and energy sectors to develop more efficient methods of harvesting energy and capturing particulate matter. The implementation of these laws that regulate the production and capture of particulate matter can greatly assist in reducing the amount of air pollution, already seeing success in various European and Asian countries. By 2015, sulfur dioxide emissions in Asia had declined by 15% relative to 2005, despite the 63% growth in GDP. Without the implementation of control measures, emissions would have, predictably, been 80% higher. However, at the end of the day, our increasing consumption of energy per person makes it difficult for cleaner and more environmentally friendly energy sources to supply everything that we need. Since Asia's energy demand is expected to increase by 32% in 2040, the implications for air pollution are rather serious, particularly when the demand is based on the need for dirty energy sources like fossil fuels. If we are to eliminate the need to burn fossil fuels for the production of energy, especially in the newly industrialized countries in Asia, it is necessary for us to change our spending habits in an energy context. Reducing our consumption of energy, either through a change of our habits or the usage of energy-efficient technology, can greatly reduce the pressure placed on the energy and industrial sectors, making it easier for them to develop and use energy that produces minimum amounts of air pollution.